Now this same thing happened, and I talked about it a while ago, where a technician had a stove and the control board wasn't working, and he changed the board and it still wasn't working. And I told him, check the voltage going to the machine, and the voltage was low going to the board, just like we're talking about with the dryer. I said, do you have a test cord like this? He says, yes, I do. And right on the side of the stove was a little counter, and it had an outlet. And he plugged it in and plugged it right to the board, line 1 to neutral, and the board came on and the oven started running. So the lady knew that there was a problem. When the guy called me, we told the lady the problem is, I don't know why the technician went back, but he went back to the customers and I says, the customer would like to ask you a question. Sure. And I explained to her it's an electrical problem and how this happened. Oh yeah, that's right, and she forgot. But this is a way for you to say to the customer, listen, you have an electrical problem. You can see the motor's running, but when it's plugged into your outlet on the wall, even though there is electricity, it's not enough for the motor to run. But that is a way to convince the customer, because the customer won't believe you unless they see it for themselves. But that's how we trouble it. This is the exact steps I told him on the phone. Check the door switch, and he ohmed out the door switch. He opened and closed, it was working. I check out the motor, he ohmed out the motor circuit, it's working. I said, check the voltage coming off the board. He had the voltage coming off the board. I said, how much voltage? And when he told me 107, I said, hey, that's low. And that's just how we solved it. Okay, can you set that back up? Because I'm gonna go on and unplug. All right, let me just rotate this and get this to a screen. And then Paul, I know you got a question, but I think I have an idea what you're gonna ask, but I wanna have this up on the screen for a second. One second, give me a second to find that screen. Well, I thought they were showing installation, weren't they? Where's installation on this thing? Safety, specifications. I'm trying to find installation.
Control F.
Yeah, but I'll probably find it in a second here. That's not gonna be right where I want it. Okay, but I'll bring up the diagram and answer your question. Okay, so your question is, what if I put the 2 power wires here?
Yes, what would it run?
What?
What would it run?
Nothing.
Nothing? Oh, okay.
Because L2 on dryers are only here to feed. If we follow that wire around, goes to a switch on the motor, it just goes to the heating elements in the dryer. And if the motor don't run, the heater won't run. So you can't directly energize the heating element from the power cord in the back. Now, could you check these heaters? You know what? I could put 110 volts on these 2 wires and put those in series. They won't get as hot, but I could get them to produce heat. And I also could check continuity. Look, watch this. If I had a heating element problem, there's 2 heating elements on this dryer, right? If I had a heating element problem, I could check here, and I could check the resistance of both of them, right? Now, if one's broken, do I get a reading? No. But if I follow this wire back, let's see, it goes to this switch, and it goes to here. I'd have to go all the way to line 2, and I go here or here, it would tell me which one is bad. But in this case, this manufacturer doesn't sell one element or the other. The double element is one piece. If one of broke is broke. So immediately I would just ohm that out if it ran and didn't heat, like in the competition. First thing I want to see is 240. If I got 240, I'd go here, check continuity. If I got continuity, then I would go here and see if I got 240 and see if one of those relays are not closing. And see if I got voltage there. But yeah, if I put the power on the wrong 2, nothing would happen. Even if I put 120 here, I'm going across the heater circuit, the motor won't run. And if the motor don't run, that switch right there is inside the motor, that's a centrifugal switch. If it don't close, the heater won't come on. So putting on the wrong two wires would not hurt anything, but it won't run anything. Okay, so let's go to the other diagram. I think I went to the wrong screen, 1 second. All right, so let's do the same scenario. Dryer doesn't run. What's the first test we're gonna make now? This is a whole new problem. Dryer don't run. That's this GE dryer. Don't run. What are you gonna do first?
Check power.
Check power where?
At
At the wall first.
the,
If you have it at the wall, then it's a good thing to check here, because 1 year, not intentional, in Orlando, we were going to state competition. I had students at this other school, and there were some guys from Sears, and they're setting up brand new power cord, and they had a dryer and a washer that they brought for the competition. So they're installing a brand new cord in the dryer, and the dryer's not running. They start checking the door switch. They had the whole machine apart, the drum out and everything. Turned out the brand new cord was bad. And the black wire, line 1 going to the machine, wasn't giving power. It's somewhere in the manufacturing of the actual brand new cord was bad. So you know what? They said, leave that in there. This is a good problem for the kids to find. Almost every kid found it like that. Because they tested the wall had power. So then they went right to the back of the machine where that cord connects, and they didn't have the same power there, and they knew immediately the cord itself was bad. But that's a smart way of doing it, because you don't want to go to someone's house and start removing a bunch of panels to service something. If you could just go right behind it, make a quick test, and you're done. Now, if the easier test doesn't find the problem, yeah, now we're going to have to take more panels off. But when we troubleshoot, we want to find the easiest way to troubleshoot. We want to do the easiest thing. We don't want to work hard. So anyways, where's our motor on this machine? Where is it physically on this machine? It's easy to find, guys.
it's over to, right?
K5.
Down here at the bottom right, it says motor. And so number 4 and 5, which is common to most machines where power goes in, where is their other end on the board? If you wanted to check this out.
K505 or K504 and O, and then
So K504NO. So I put a meter here.
and then J101N.
J101N, which would be here, so that would be this side of the motor, and it would bounce up and go up that way. Can you guys see those circuits? Right there. So this is line 1 or neutral?
That one's line 1.
That's line 1 because that's neutral. So I can do 2 tests here. What 2 tests can I do? Okay, I can do continuity and check the resistance of this motor. Or I could do what?
Voltage.
Voltage from that same point to see if the board's sending voltage down. Okay, so for the heck of it, let's take a look. Y'all come over here and look at the board on this machine. So J101 is a white wire, and this one's a purple wire, right? So this is a purple wire right here. What is this relay? Now, one of them's labeled normally open, one's normally closed. It's probably this one right here. This wire right here is that purple wire on the board over there coming off of K504. And then the white wire, J101, would have to be the white wire there. Okay? So you could check voltage on that wire and this pin. And if you have voltage, what does that mean?
That there's power going through.
What does that mean?
That the motor is getting power.
That the board is sending power. It's not saying the
Sorry,
motor is
correct.
getting power, because yes, if we ohmed out the circuit and the circuit was good, but if we had power here and the motor wasn't running, then the problem is down towards the motor. We know that the board is trying to tell the motor to run, but it's not running. Okay, so if you guys want, you can turn the camera off. Let's do an ohms test. Let's get a